Hello, and thank you for joining us for our live webinar, Choosing a Conductivity Logger, 5 Important Considerations. We are joined by Paul Gannett, Product Marketing Manager with Onset. Today, Paul will highlight 5 important considerations in selecting and deploying a conductivity logger. The webcast will run for approximately 20 minutes, and then we will open the webinar up for questions. First, I'd like to welcome Paul. Welcome, Paul.
Thank you. Good afternoon, everyone. As Jennifer mentioned, I'm going to be going through considerations that you'll want to keep in mind as you're looking at conductivity loggers. And for organizing those considerations, basically I'm going to be looking at them in these areas: accuracy, ease of deployment, data offload, software capabilities, cost of ownership, and deployment considerations. So jumping right on into accuracy considerations. The reality of the situation is when you leave something out in the water for a long time, there's going to be sensor fouling. This is a sensor that's been out for a couple of months. Any number of things can happen. You can get algae growth, you can get sediment buildup, you can get just general slime building up on your sensor. So in addition to the actual accuracy of the logger, you need to have ways of dealing with these real-world effects. So some of the things to keep in mind that will help with that. First off, think about the type of sensor technology. There's basically non-contact sensors and electrode-based sensors. And the non-contact sensors are more, or let's say the non-contact sensors are less likely to drift than electrode sensors. Basically, the reason for that is electrode-based sensors, any slime or buildup that's on the sensor, that's going to directly be in the measurement path for your measurement. Whereas a non-contact measurement, first off, there's no chance for conductivity, or no chance for sensor tarnishing because the sensor's not in contact with the water. So that's one effect that you don't have to worry about with a non-contact sensor. And the other advantage of a non-contact sensor is that it's indirectly measuring the conductance. So the any slime on there doesn't have as direct an effect on that measurement. So generally, I'd recommend a non-contact sensor. Secondly, does the software that comes with that data logger include some compensation for measurement drift? And typically, what happens is most software that you get with your data logger includes a way to enter calibration readings, and those calibration readings can be used to adjust your conductivity measurements to get improved accuracy. Even better yet is if you can have software that allows you to enter a couple of calibration readings from, let's say, the start of the deployment and the end of the deployment. It can make some adjustments for drift that happens during the deployment. The next thing is frequent sensor cleaning is going to help your accuracy. So every time you pull your logger out, you want to clean the sensor, and that's going to reduce the buildup of slime and the effect of that on your measurements. Another thing to keep in mind relative to accuracy is that the conductance of water changes with temperature. So as your temperature changes, your conductivity is going to change. So to adjust for that, what the standard for expressing conductivity is specific conductance at 25 degrees C. At least that's the most common standard. So any conductivity measurements that you take have to be converted to specific conductance at 25 degrees C. To do that accurately, you need a very accurate temperature measurement, and that temperature measurement must be taken right at the conductivity sensor. Otherwise, any errors in your temperature can lead to an error in your conversion to specific conductance. The next factor to consider when selecting the conductivity logger is how you're going to mount it and deploy it. And here's some things to think about. One is does the data logger sink or does it float? Generally, if it sinks, that makes it easier to deploy. You can put it in a well, such as is shown here. This is a pretty typical way of mounting a conductivity logger, hanging it in a well, and just letting it, sink to within the water table. Another thing to keep in mind is the size of the data logger. Generally, the smaller the data logger is, the easier it is to deploy, as well as the easier it is to transport out to the deployment site. Another thing to keep in mind is just look for an eyelet or something to hang the data logger in the water. Again, as you can see from mounting it in a well, that makes it easier to mount in a well. In terms of data offload, it really helps to have some sort of data shuttle, some sort of handheld device that you can take out into the field and use that to offload the data. That's a lot easier than having to take a laptop out into the field with a base station because it's sometimes tricky in the field to balance the laptop and the base station and read out the data logger all at once. So a handheld data shuttle makes your job a lot easier. Next, you want to think about software capabilities to support the data logger. Software is your interface to the data logger, so obviously the easier the software is to use, the easier it is going to be to set up your data logger. So here's some things to look for. One is, as I mentioned before, the data has to get converted to specific conductance at 25 degrees Celsius. So look for software that has a choice of methods for converting your conductivity readings to specific conductance at 25 degrees C. If you're in freshwater, look for a freshwater conversion. So just make sure that the method that you want to use to get specific conductance is supported in your software. The next thing, I mentioned this earlier as well, is the ability to enter those field calibration readings that you take out of the deployment site. Take those field readings and enter them into the software, and let the software do the work of coming up with a calibrated conductivity measurement. And ideally, if your software supports it, it's nice to be able to enter points from both the beginning and the end of the deployment and have the software